Hey, good morning or good evening, everyone. This is a short class, but it could be very beneficial to your foundation design. As we know, IBC 2018 relied on ASCE 716 for detailed design of foundations. ASCE 716 as a complete new section 12.13.5 is a strengths design for foundation geotechnical capacity. So this indicates you can now do the ARFD design for the geotechnical capacity, as the people do for the asphalt, for the bridge design. A lot of good stuffs in this new section. In this class, I only cover the seismic lateral resistance. So this is a code requirement to determine resistance to lateral nodes. The interesting thing is what I highlight in red, lateral bearing pressure. So the immediate question is what is the lateral bearing pressure? We know the vertical bearing pressure, basically the bearing capacity of the foundation. So here is what I found from the commentary. So the lateral bearing pressure is a passive resistance from soil rock that represent a reduced allowable value determined to meet a defined deformation limit. So one thing you need to pay attention is that it doesn't say you can use full passive resistance. It says a reduced allowable value determined to meet a defined deformation limit. So I will talk about this issue in the next slide. Another interesting thing is horizontal sliding resistance. It doesn't like before, you can only consider the lateral friction resistance beneath the foundation. Now you can consider the side friction along the foundation. So for the deep foundation, it's similar. So if you want to get a pi group capacity, now you can consider, part of the passive resistance of the pi cap. So this could be very beneficial for your pi foundation design, particularly when it's very challenging to lay out the pies for limited footprint to get enough lateral capacity. So what is a allowable value for defined deformation? So basically, you need a relatively large movement to fully mobilize passive resistance. Typically you need several inches. So unfortunately, most foundations don't move that much for performance requirement unless you have something very simple foundation like electric car charge station. Maybe that doesn't matter, it can move a lot. So then the big question is how much passive resistance can be considered for your design. Unfortunately, the commentary doesn't provide clear direction how to do that. Certainly you can run some numeric soil structure analysis to determine how much passive resistance is mobilized. Another good reference, I think, is a very simple approach you can use. That is from the famous 356 seismic rehabilitation pre-standard. So basically provide a chart. So the horizontal axis just to say that's your movement over your foundation thickness, and the vertical axis you say what percentage of passive resistance are mobilized associated your foundation movement. So this could be very useful. A chart, you can use that to determine how much passive passive resistance is mobilized. One thing I want to point out, if you look at this chart, it's not a linear relationship. So that means, even at very small movement, let's say 0.5-inch movement, you could get a 50% passive resistance. So this would be a very, very helpful for your foundation design when you deal with the sliding and overturning issue. So I want to talk about a little bit more about this. There are several design-related issues. One thing is, this section is in the seismic design code requirement. Some people may ask, can this approach be used for the wind node case? My answer would be yes, because this is the kind of resistance is there no matter what kind of noding is, but you definitely need to confirm with client or client's engineers. Another thing that some people may worry about, your soil compaction around the foundation may not good enough. So how you kind of make sure, your soil and the foundation, they are contact to each other. Certainly you have to look at what kind of soil backfill around the foundation, and what kind of soil type. So in my mind, it may be kind of not very good approach to consider the side friction. Sometimes you may have concern they are not entirely contact to each other, the foundation and the soil. But for the passive resistance, since your foundation will move certain amount of maybe couple inches, so I think definitely you can consider the passive resistance for your design. So one thing, if you really want to use this approach, sometimes you may need to communicate with the clients, for large deformation, lateral deformation requirement. Remember, when you have sliding or overturning issue, typically they're for the seismic node case. So think about this: the design goal for a seismic case for 2,500 year return earthquake. The design goal is not make sure this foundation stay operation. The goal is to preventing collapse. So you need to keep this in mind when you're talking to the client. The next issue is very important. So when you have the passive pressure at one side of foundation, you need to include the active soil pressure at another side of your foundation. Otherwise, your design is wrong and definitely not a conservative. So that's all for my today's class. I hope you learn something that can apply to your foundation design that eventually will save the money for you and your client. So if you have any question, send me the email or leave a comments underneath this video. Thank you very much.